So looking at number 19 right here, it says determine if the sequence is arithmetic, geometric, or neither. Now we need to know that an arithmetic sequence has a common difference d, and a geometric sequence has a common ratio r. Okay, so what you need to do, whether you're finding a common difference or a common ratio, is to pick a number and then either subtract the previous number from it or divide it by the previous number. So if I pick the number 20 and divide it by 100 to check if it has a common ratio, that would be 20 divided by 100. And of course the zeros cancel, reduce it, 2/10 reduces down to 1/5. But it needs to be common, all right? So if I divide 4 by 20, will that also give me 1/5? And if you reduce by 4, yes, it will give you 1/5 as well. And last but not least, if I divide 2 by 4, 2 divided by 4, will that give me 1/5? That does not give me 1/5. It only gives me 1/2. So what looked like it could have been a geometric sequence, it's not. Why is it not? Because the ratio is not common. We got a ratio of 1/5, a ratio of 1/5, got a ratio of 1/2. That did not work. So if you try common difference, like if you go 2 take away 4, 2 take away 4, that's -2. But if you try 20 take away 100, that's -80. So there's no common difference either. So on this particular problem, we would say neither. Okay? And the explanation is because there is no common ratio or no common difference. I'll move on to number 20. It says find the next 3 terms in the following geometric sequence. So they're telling you on this problem that it's geometric, which means that there's a common ratio involved. Okay? So you don't need to make sure that it's common. They're telling you that there's a common ratio. So let's just pick any number and divide it by the previous. Now, if you like doing a lot of work, go ahead and do 36 divided by 216. I, on the other hand, like it nice and simple, 1 divided by 6. So the common ratio is 1/6 on this problem. Now, what that tells me is how my number, my first number, changes to my second number. So the 216 changes to 36 by multiplying by 1/6. The 36, if I multiply it by 1/6, it changes to 6. The 6 times 1/6 changes to 1. So the common ratio tells you how your numbers are changing. Same thing with the common difference. The only difference is that when you're saying common difference, you're adding or subtracting the common difference. On the common ratio, you're multiplying by it. So to get, now let's understand this, the notation. A sub 1 is that one, A sub 2, A sub 3, A sub 4. They want the next 3 terms. So they want A sub 5. What's that going to be on this problem? I take 1, I multiply it by 1/6. What do I get? 1/6. So let's go A sub 6. That's going to be the next term. And the way to get that is to take this output of 1/6 and multiply it by the common ratio again to get to the next one. So what's that going to be on this problem? 1 over 36. And the very last one, A sub 7, the third term that they want from at the end of this list, I'm going to take the 1 over 36 and multiply it by 1/6 again. I'm going to use a calculator so I don't mess up. And I'll get 1 over 216. So those are my next 3 terms. 1/6, 1 over 36, and 1 over 216. Moving on to number 21A. Write an equation for the nth term of the geometric sequence. Okay, in order for us to do this, we need to remember the a sub nth rule for a geometric sequence. A sub n equals a sub 1, your first term, times the common ratio. You're going to find that by dividing a number by the previous number to the power of n minus 1. And that n is what you're going to be plugging in to get your output. N is your input, the answer is your output. Anyway, if I want to write my equation that produces this list, I first need to have this memorized. Secondly, I need to plug in my appropriate values. A sub 1 is what on this list? Negative 108, right? So we plug in negative 108 for my a sub 1 the common ratio, I need to figure that out. So I need to take a number and divide it by the previous number. So if I have 32 divided by 48, of course with the negative out in the front, because the 48 is negative, I could reduce that by 8. And that would give me 4, 6. And I could reduce that by 2. So that would give me 2/3. So my common ratio is 2/3. And of course the Casio calculator could do that for you. All you do is divide 32 divided by negative 48. It'll give you negative 2/3. Sorry, I forgot the negative. Or you could have done it here. 72 divided by negative 108. That'll also give you negative 2/3. So your common ratio is negative 2/3. Let's put that common ratio in here, negative 2/3. And it is to the n minus 1 power. So let me rewrite my a sub nth rule nice and neat. A sub n equals negative 108 parenthesis negative 2/3 to the n minus 1 power. Now they want us to find the sixth term. So the notation for finding the sixth term would simply be a sub 6. That has nothing to do with math. That's just the name of what we're going to be doing. What this says is that I'm going to plug in 6 in place of the n. So when I rewrite this whole thing, I'll have negative 108 parenthesis negative 2/3, and I'm plugging in a 6 in place of the n. So there's a 6 up there instead of the n, but it still has a minus 1 up there. So what we're going to be doing on our calculators is typing in negative 108 parenthesis negative 2/3 close parenthesis to the power of 5. That's what we type in on our calculators, and we should be able to get the answer. So on your calculator, you should type in the negative 108 and then open up some parentheses. And inside the parentheses, you're going to hit this fraction button. And you type in the negative 2/3, close parenthesis, and then you're going to hit the power button, which is this one, X to the box. And then you put a 5 up there. And when you hit equal, you get this funky answer, 128 over 9. So that is your answer, 128 over 9. Let's move on. So simplifying radicals is fun. This is where you split the square roots. This is where when you have the square root of a variable to an even power, you simply divide it by 2. So let's start with number 22 right here. We're going to split that square root and put it on the 125 and put it on the b to the 9th. Now, when I have a square root, I want a perfect square number, and 125 is not a perfect square number. But I could rewrite it with multiplication to get a perfect square number. What would that be?
25 times 5.
25 times 5. That way, when you split the root, you could actually do the square root of 25, which is 5, and the square root of 5 just comes down. Now, the same thing with the square root of b to the 9th. I hope we remember that a square root is the power of 1/2, which means that you would like this to be divisible by 2, but it's not, right? Because the power of 1/2, 9 times half, you end up with 4.5. So this is not divisible by 2. So let's rewrite it with multiplication to get what we want, an even power, something that's divisible by 2. Kind of like over here, I wanted a perfect square number. I rewrote it with multiplication to get what I wanted. Right here, I want an even power, so I'm going to rewrite it with multiplication to get what I want, which is a b to the 8th times b to the 1. Now I could split the root, and now I could actually do the square root of b to the 8th. Again, that's like dividing 8 by 2, so that'll give me b to the 4th, no more square root. And the other square root of b, you can't really do that, so just bring it down, the square root of b. Now this is our answer in blue, but we need to arrange it, we need to organize it. I want to put the 5 and the b to the 4th together. And then I'm going to put the square root of 5 and b together underneath one square root. So there's my answer, 5b to the 4th, square root of 5b. Number 23. This one's fun. radicals, you could first realize that there's nothing but multiplication. This says 3 times the square root of something times 5 times the square root of something. So it's all pure multiplication. You could rearrange things, guys. You're going to have the 3 times 5. You could actually do that. Then you could put the square root of 2y times the square root of 10y right next to each other. Now we could actually do 3 times 5. We'll get 15. And the square root of 2y times the square root of 10y, those are both radicals. You could multiply them together and put them underneath one radical. So I could put the square root of 20y squared. Does that make sense?
Y squared.
Because y times y is y squared. And 2 times 10 is 20. Now, we still can continue simplifying the square root. So let's split the square root to the 20 and to the y squared, because the square root of y squared is what? The square root of y squared is what? It's just y. Now, how about the square root of 20? That'll break down to 4 times 5, which means you could split the root and you'll have 2 square root of 5. And let's not forget about this 15 that's out here. So I really have a 15 times 2 square root of 5. So my final answer will be 15 times 2, which is 30. Let's not forget about this y that's being multiplied over here. So it's really 30y. And then bring down the square root of 5. So your final answer is 30y square root of 5. 30y square root of 5. There's many ways of doing them. You could have done it a different way, but let's move on. Zoo tickets. Tickets to a zoo cost $10 for adults, $9 for children. Class took a field trip and purchased 28 tickets for $266. How many students' tickets were purchased? So this is a word problem that you have to create a system of equations for. So anytime you're dealing with a real-world situation that involves money and the number of items, you're going to create a system based on money and number of items. So check this out. Let's create an equation based on money. Well, we know that each adult costs $10. So here's my equation for money. It's $10 for each what? Adult. So I'm going to put 10 times A or just 10A. And then I know that there's also $9 for each child or student or whatever you want to call it. So I know that I also spent a total of how much money? 266, according to my problem here, right? So you guys are going to have to create an equation based on money. Now, you're also going to have to make an equation based on number of tickets, right? Number of tickets. So do we know how many adult tickets were sold? No, I put A. Do we know how many children tickets were sold? No. But we do know how many total tickets were sold. How many? Okay, on mine it says 28. So I put 28 right there. So you see, we created one equation based on specifically on money. The other equation was based on number of tickets. I don't know how many adults, I don't know how many children, but I know when I add them together it's a total of 28 because it says we purchased 28 tickets. So ladies and gentlemen, that's the hard part. That's your system now. Here's your system. You need to solve the system. I would use elimination method. You either want to get the A's to cancel or the C's to cancel. It's totally up to you. So you want the C's to cancel? All right, let's cancel. By the way, I'm realizing something. The word problem's funky because we're talking about children, then it says student. I guess children are student. My bad. Anyway, so you guys want to cancel out C's? Yeah. All right, so if you want to cancel out C's, you would have to multiply the bottom equation by -9. I'd multiply by -9 so I could get a -9C, so it'll cancel with the positive 9C. So the top equation I'm not going to mess with. It's going to be 10A plus 9C equals 266. Now the bottom equation, I'm going to go -9 times A, that's -9A, -9 times C, that's -9C, and 28 times -9. And we'll get -252 on my problem right here.
Why are you getting rid of the students if we're trying to find the student?
now that we're ready to combine the lines to eliminate the C's, 10 take away 9 is 1. So we could just say A, and the C's cancel out. The equal sign comes down, and 266 take away 254 is 14. So I really have 14 adults, right? Zoo tickets. How many adult tickets were purchased? 14 of them. Now, if we want to find out children's tickets or student tickets, because that's what they're really asking for right here, saying how many student tickets, not adult tickets, were purchased. So all you have to do is plug it back in. Now I'm going to take this 14, put it in right here. So it's going to say 14 plus C equals 28. And if you subtract 14 on both sides, you get C equals 14 as well. So right here is pretty interesting. Both A and C are the same number. Any questions? Of course, the better option would have been to cancel out A's instead of C's, right? If we would have multiplied everything by negative 10 instead of negative 9, then the A's would have canceled. We would have had C, and it would have given us our answer more directly. How many student tickets? That would have been C equals whatever it was, which is 14. All right, let's try number 25 here. On this one, this is just straight up. It's a system. You're going to have to modify both equations to get something to cancel. So you either cancel out x's or cancel out y's. It's totally up to you. I would choose the cancel out y's. And the reason for that is because I would rather deal with 3 and 5 instead of 8 and 7. Right? In order for the 8 and the 7 to cancel, I'd have to get a 56 and a negative 56. You get pretty big numbers, both on top and bottom equation. But 3 and 5 are a little bit smaller, so that's what I'm going to use. I want to convert this positive 3 to a positive 15 by multiplying everything by 5. And then I want to convert the bottom 5 to a negative 15. I want to change that 5 to a negative 15 by multiplying the whole thing by a negative 3. So up on top, 5 times 8 is 40x. 5 times 3 is 15y. 5 times 4 is 20. The bottom equation, negative 3 times negative 7, that's positive 21 with an x. Negative 3 times 5, that's negative 15 with the y. Negative 3 times negative 34, that's positive 102. You guys with me? Now I'm able to combine the lines and eliminate the y's. I'll get 61x equals 122. Big numbers, but it's okay because when I divide by 61, I'll get x equals 2. And that's one answer. You need the other. Take that 2, plug it back into any equation you want. I want to rewrite the top equation, 8x plus 3y equals 4. But instead of x, I want to erase the x, and I want to put a parenthesis right there so I could plug in this 2 right in there. So I really have 8 times 2, which is 16, plus 3y equals 4. I need to get rid of the 16 by subtracting 16 on both sides. And you will get 3y equals negative 12. Final step would be to get rid of this multiplied by 3 by dividing by 3. You get y equals negative 4. So the final answer to this final question on the review is the ordered pair 2, negative 4. I hope this helps.